Welcome to How to Construct a Two-Sample Z-Interval. If you ever try to figure out the difference between two population proportions, well, you've come to the right place because the only way to figure that out is with the two-sample Z-interval. So let's just dive right into a question here. What is the difference between the proportion of teenage girls that do their homework every night and the proportion of teenage boys that do their homework every night at a large high school? Now, essentially, we're looking at two population proportions. We got the girls, we got the boys. We don't know which one's bigger. Is that one bigger? Is that one bigger? Is that one smaller? Is that one smaller? What is the difference? I mean, maybe they're even the same, but the point is we don't know the true population of all the girls in the school that do their homework every night, nor do we know the true population of boys in the school that do their homework every night. But we can take a sample of girls and we can take a sample of boys and try to use that sample to try to figure out what the true difference between them could be. So let's dive right into how we're going to do this. All right, first, like I said, we need to get a sample. So let's just say we get a random sample of 230 teenage girls and 184 said yes, they do their homework. That is a sample proportion of 0.8. And then we get a random sample of 250 teenage boys from the school, 180 that they said yes, that they do their homework every night. That's a sample proportion of 0.72. So we are seeing a difference, and again, you need two numbers to get a difference. The difference between our two sample proportions is 0.08. Now, our sample did show that the girls had 8% more that do their homework in the sample, or for the boys, 8% less. But the key thing is that this is just the difference between two samples. Maybe I get two different samples and they're the same. Maybe I get two different samples and the boys are bigger by 1%. Maybe I get two different samples and the girls are bigger by 12%. The point is this is just one difference between two samples. So let's construct a confidence interval for what the true difference between the population of all the girls is and the proportion from all the boys is. So let's dive right into the 4 steps. It's actually a pretty easy process. So the 4 steps are to first name the test. That is a two-sample Z-interval for the difference between population proportions. But we also got to make sure that we talk about that in context. Always want to talk about that in context. So step 1 is basically identifying what the heck you're trying to find and making sure you say you're going to find it. And then step 2 is to check the 4 conditions for the sampling distribution of the difference between two population proportions for both samples. We'll run through those conditions in a moment. Then the 3rd step is the fun part. This is where we actually build our interval. We start off with our sample difference. That is the difference between our two samples. And then we add and subtract what we call the margin of error. The margin of error is this entire back part, which is the multiplication of our critical value Z star times our standard error. Now, the 4th and final step is to interpret the interval in context, starting with I'm 95% confident or 98, 99, whatever it is that you're working with. All right, let's look at my problem about looking at the proportion of boys versus girls and trying to find the true difference. All right, so step 1 is, again, just naming, hey, this is a two-sample Z-interval for the difference. Difference between what? Copy this from the problem. The question literally asks you this. So between the proportion of girls and boys that do their homework every night at this large high school. Make sure that you're representing the fact that we're looking for the true proportion, the true population difference between these values. We already know the difference between our samples is 0.08. We're not looking for that. What we're looking for is the difference between the population proportions. All right, step 2 is checking those conditions. As I mentioned, there's 4 of them. They should sound pretty familiar if you've been doing your work. Step 1, or condition 1, make sure that both samples of the boys and girls are randomly selected to avoid bias. Condition 2 is make sure the sample of the girls is under 10% of all teenage girls. It did say it's a large high school. Don't know exactly how many girls are in the high school, but I'm just going to have to trust the fact that 230 teenage girls is under 10% of all of them. Same thing for the boys. 250 boys needs to be under 10% of all the teenage boys to assume independence. All right, finally, we need to be big enough. That means that working with proportions, each sample has 10 or more successes. That means they did their homework, and 10 or more failures. Those are the kids that did not. Well, in the sample of girls, we were literally told that 184 did their homework out of 230. That leaves 46 that did not. Both of those numbers are 10 or more. In the sample of boys, we were literally told that 180 did their homework. That's obviously 10 or more. And that would tell us of the 250 boys, 70 did not. Now, if you're in a problem that did not give you how many people had those successes for this or that, and you were given the proportions, well, then you would have to take the proportion, multiply by the sample size to get those actual values. All right, lastly, when you're working with two samples, we do need to make sure that the two samples are independent of each other. And oftentimes we just have to assume that that is going to be true. Obviously, we want the boys to be completely separate from the girls sample, and that should be easily true. All right, now the third step is the fun part. This is where we actually build the interval. Now on the AP test, they love it. They love when you actually write down the formula. So you're identifying what you're going to do. I'm going to take the difference between my two samples, which again is one number, but it takes two numbers to get a difference. And then we're going to add and we're going to subtract by this margin of error. So much fun, right? All right, so first we're going to take the boys minus the girls, and that's how I got the 0.08. Then we're going to calculate our margin of error, starting with our critical value. Very easy to get that critical value. You could use a T, or not a T, oh my gosh, excuse me. You can use one of your Z tables, or you could use your TI-84 calculator, which I'll show you right now. So we're going to hit second vars. We're going to do an invert norm. Now, it did ask us to do a 95% confidence interval. So keep in mind that that means there's 95% in the middle. So if I leave that tail on the left, now if you don't even have that option, it's automatically set on the left. But if there's 95% in the middle, that means 5% is left out. 2.5 at the top, 2.5 at the bottom. So I'm going to put 0.025 as that bottom area. And this is how I'm going to get that critical value 1.96. There it is. Now for the standard error formula. This is a pretty simple formula, not overly complicated. And it's given to you on formula sheets. It is taking the sample proportion for the girls, multiplied by the opposite of it, divided by the number of girls. And then the same thing for the boys, sample proportion for the boys, the opposite, and the sample size. Remember that we're working with proportions here. I know that we were originally given the counts, but we never want to build an interval for the counts. We're building an interval for the difference between the proportions. All right, multiply all that together on your calculator. We get 0.0760 for our margin of error. So of course we're going to subtract it, and then we're going to add it to get our interval, 0.004 or 0.4% to as high as 0.156 or 15.6%. All right, now it's time to interpret what the heck this interval is saying. Now, I'm going to give you two interpretations, but I'm going to give you the one that I actually prefer. First, we just start out by saying, hey, I'm 95% confident that the difference between the proportion of teenage boys that do their homework each night and the proportion of teenage girls that do their homework every night, excuse me, I said boys first, but girls first, then boys, is somewhere between 0.4% and 15.6%. So again, remember what we were looking for. We were looking for the difference between the proportion of teenage girls and boys that do their homework. Well, I don't know exactly what it is, but I'm pretty confident, 95%, that it's somewhere between 0.4% and 15.6%. Now that's a great interpretation, but I like the second one better. Because anytime you're looking at two things, anytime you're looking at the difference between two different populations, it makes way more sense to actually compare them. So this is a sentence that makes a comparison instead of just informing what that difference could be. So here I'm saying, listen, my entire interval was positive. I did the proportion of girls in my sample minus the proportion of boys in my sample. And based on that, I got a 0.08. And when I added and I subtracted, both sides of my interval are positive. So here's what I know. I'm 95% confident that the proportion of teenage girls that do their homework each night is anywhere from 0.4% higher, again, positive, if the girls were first, and a positive is what you get, that means the girls were higher, to anywhere to 15.6% higher than the proportion of teenage boys that did their homework each night. So it's really important, in my opinion, to actually go ahead and compare those by saying, hey, listen, my entire interval was positive. I was specifically looking at girls minus boys. And if I'm going to get a positive number, that means the proportion of girls is bigger. How much bigger? Well, that's what I don't know for sure. But I think it's anywhere from 0.4% bigger to 15.6% bigger. So I guess I do have significant evidence, or I do feel confident, 95% confident, that the proportion of girls at this school that do their homework every night is more than the proportion of boys. But let's just play a quick what-if game very quickly. What if I got this interval? Again, this is just something I just quickly made up, but I want you to point out, or I want to point out that in this interval, the left side is negative and the right side is positive. Now think about what that means for a second. I specifically, when I constructed my interval, I was looking at the proportion of girls in my sample minus the proportion of boys in my sample. So what would a negative value mean? A negative value would mean that the girl sample would actually potentially be lower. So that would mean that the proportion of boys could be 1.2% higher than the proportion of girls. Or I could say the proportion of girls could be 1.2% lower than the proportion of boys. But a negative would mean, in the order that I did it, girls minus boys, would actually mean that the second value, the proportion of boys, is bigger, which is possible. Now, the other side is positive. And again, positive goes back to what I already said. Positive means that the first number is bigger. That means the proportion of girls is bigger. So this interval could tell me that I actually don't know if the proportion of boys or the proportion of girls is larger that do their homework every night. The boys could be larger or the girls could be larger, or guess what? Another number that's in this interval is 0, which means there potentially could be absolutely no difference between the proportion of boys and girls at this large school that do their homework every night. So that's an important point to note when you get an interval that has a negative on one side and a positive on the other. Now, the last thing I want to show you real quickly is how this can all be done on your calculator. Oh, let me talk about it real quick first. On your TI-84 calculator, this is called a 2-proportion Z interval. 2 proportions, and it's a Z interval. Anytime you work with a proportion, you're working with Z. Now, when you go and do this, we're going to hit Stat, slide over to Tests, and you got to scroll down for a little bit to find it. 2-proportion Z interval. There it is, all the way down towards the bottom here. And it's going to ask you for a couple things. It's going to ask you for X1, that is the successes for population 1. So that was my girls. There were 184 successes. Then the sample size for population 1, that was my girls, 230. X2 is the successes for the second population for my boys. That was 180. And then the sample size for that second was 250. Now, I'll say this one more time. If a problem does not give you the number of successes, it gives you the proportion of, you do need to multiply by your sample size because you have to type in the successes. You can't type in the proportions here, just how it works. It also doesn't accept decimals. So if you do have a percentage given to you and you multiply by your sample size and you don't get an exact whole number, just round it to the nearest whole value. All right, then for the C level, we're going to type in 0.095. That was our confidence level that we were asked to use. Hit calculate, and boom, there it is. Pretty darn close to what I got. If anything, this is exact. Now notice what it gives me. It first gives me the interval that says that the proportion of girls in the population could be anywhere from 0.4% higher to 15.6% higher. But it also gives me my sample proportions, which I knew anyway, and my sample sizes. All right, pretty cool that it could calculate that really, really quickly for you. All right, that's it for this video. Hopefully you learned how to do this. Short and sweet. See you in the next video.